Hi, this is Clarence speaking. We're going to be exploring two problems from the Heart of Algebra portion of the SAT, particularly dealing with system of linear equations. A system of equation refers to two or more equations that deal with the same set of variables. There are two main ways of solving a system of two equations, substitution and elimination. On the test, you will most definitely run into a question that asks you to translate a situation into a system of equation. Let's take a look at this class example. A group of 30 students order lunch from a restaurant. They either get a burger or a salad. The price of the burger and salad is also given, $5 and $6 respectively. The group spent a total of $162. How many ordered burgers? First off, we start from defining the variables. We're going to let X be the number of students who ordered burgers. Number of students who ordered burgers. We're going to let Y be the number who ordered salad. We can then make two equations right here. X plus Y equals 30. This is the amount of people who order burgers plus the amount of people who order salad. They should be in total 30 because we have a group of 30 students here. Then we're going to deal with the price and the cost. 5X, that's an amount they paid for burgers. And 6Y for salad. They add up to 162. In this case, we're going to use elimination. We're going to multiply 6 to the first equation. I'm going to keep the second equation the same. And we're going to subtract. All I could do is put a negative sign here. 6x minus 5x, that gives us 1x. 6y minus 6y, that's gone. What we have here, 180 minus 162, 18. That means there are 18 students who order burgers. We're not going to substitute it back in to find the y value. The people who order salads because the question did not ask for that. You might encounter a system of equations that are a bit more complicated than the standard one we just did. For these systems, substitution and some equation manipulation will typically do the trick. Realize here we have a quadratic. That means we're going to get two values for x. But we want the value that also makes y positive, right here. This just means we want a positive y value, right? Y is greater than 0. In the first equation, we're going to isolate y. We're going to get y equals negative 3x. By plugging this into the second equation, we will have x squared plus 2 times negative 3x squared equals 76. In this case, we got rid of y. Now it's in terms of x. And let's just simplify this. Do some mental math here. All right. I'm going to get x squared equals 4, which also means that x is plus or minus 2. Now, which one do we know that's going to make y positive? Well, we're going to substitute it back in, right? If x equals 2, then y is going to be negative 6. How do I know that? Well, all I did was plug into this first equation here. If x is negative 2, then y is going to be 6. That one gave us a positive y value.